Hello, sir. I'm here to present my fourth capstone project, which is on the data visualization. And the tool I'm using, the BI tool I'm using for this data visualization project is Tableau. To begin with, we are on the data source page of Tableau Public. Here I have loaded two CSVs, titles cleaned and credits cleaned, and I've established a one-to-many relationship between these. And these CSV have been cleaned and processed in Jupyter Notebook. So for that, this is all for data source page. For the worksheet, here we have in the data pane, we have credits clean CSV, titles clean CSV, and there are some of the other measures that I have created for analysis purpose. Here we have in credits we have character ID, name, person ID, and role. So all these are actually dimensions. We can see here it from the blue pill. And for title CSV, we have all these dimensions, and the IMDb score, TMDb score, and all these are the measures which we can see from the green pill. And others are the calculated fields that I have created. So for the first chart, I have created first KPI, which is total titles. This is nothing but the count distinct of ID, and we get total 9,791 titles in the titles catalog. Same, we have another KPI card, which is percentage of movies. So amongst the total titles, 86.9% of titles are movies, and the rest of them, that is 13.1%, are actually shows. The same has been shown from the horizontal bar chart. But for the sake of visualization, we can see that the movies contribute to a larger part than shows. Now we have here labeled them with count. The blue bar will always show movies. The orange bar will always show shows. For the rest of the visualizations, rest is very simple. It's the count distinct for ID in columns and type in rows. Okay. The fourth chart is actually the distribution of IMDb scores. So this is a histogram. I've created a histogram. Uh, for creating histogram, I have actually created IMDb scores bins. The size of the bin is, we can see here, 0.5 actually. So in that way, the IMDb scores from 1 to 10 have been divided into 20 parts, with 0.5 rating being the size of a bin. And we for the y-axis, we have actually taken the counts, the count distinct of titles. Here we can see that the movies, the blue chart shows the movies, the orange one shows the shows, and from this histogram we can see that the distribution of the IMDb score is more or less normal. We can see a bell curve with the peak at 5.5, with the total number of movies 2012. Number of movies fall between 5.5 to 6 of the IMDb, so that is the mean. For the score, for the shows, we can see that the distribution is actually a little bit scattered. We see two peaks here at 5.5 and 7, and this is how the histogram, this is how is the distribution of the IMDb scores in US Amazon Prime catalog. The first dashboard that we have is actually the overview of Amazon Prime. It shows the total number of titles that we have in the dataset, the percentage of movies in that title, and percentage of shows in that title. The same has been showed by the horizontal bar chart, but we can see the counts here, and we can see the distribution of IMDb. Okay, so what we have done is we have created this dashboard using a floating type. Okay, only one container have been used, which is the vertical container, and after that we have designed the dashboard according to our own will, completely without the use of any other objects. These are the objects that can be used, but I have not used any of the objects. I've used my own design to design the first dashboard. Moving on, we have one more chart, which is the top 10 producing countries. So in the Amazon Prime catalog, we have a dimension called production countries. So that production countries actually had a list of countries in which the movie was produced. Okay, so we have split that, and we have created another dimension called production countries individual. This is the name, and we have given it a geographical role. We can see here, production countries individual, and we have given it a geographical role, which is why we can create a map here. And the circle, the size of the circle actually show what amount of titles have been produced in which country. So the US has the biggest circle, which we can see. Obviously it is a US prime catalog, and almost 4,700 plus titles have been produced. It's like more than 50% of the titles have been produced in US. Then we have Great Britain with 659, India with 1047, then we have Japan with 168, then we have Australia with 142, then we have Canada here with 321. These are almost all the titles that we can see here. For creating a map, I have used the map chart from here, where for dimension I have given the geographical role. For the measure, it's the count distinct of the ID. The next chart is important. So this chart actually shows the volume of titles released in every decade. Okay, so the prime catalog have uh, data from 1910 to 2022. So that's how it is. So for decades we have this from 10, 20, 30, 40 and so on. So we can see the peak around 2010 to 2020 has been enormous. So this chart actually shows the distribution of the volume of content being produced in different time zones. So this is about the temporal growth of the catalog. For creating this chart, I have put release year in columns, count distinct in rows, and we have put type in filters. Again, movies are being shown by blue and shows have been shown by orange. The next chart is runtime per decade. So actually, this chart shows the average movie runtime by decade. So this is only for movies. So we can see that the filter is about movies. The reason I've chosen movies is because movies contribute to almost 67% of the catalog. So the distribution of movies make more sense because they have been released throughout the catalog. We can see that the shows have been released since later, and just one or two shows have been released in what 19 till 1995. Till 1995 we have seen just two shows being released, so it doesn't make sense to find out the runtime per decade for shows. This is why we have created movies. Okay, so we can see the labels. Okay, so the this is the average runtime in minutes. For 1910 we can see that it was 84. So this is the trajectory which shows the different runtime. Why this is important is because later we can see that the IMDb scores change with the runtime, and we can find out insights that which what should be the ideal runtime for movies to get rated high and also to get a good audience response. It peaks at 101 minutes in 1980s, but other than that, it has been more or less stable. Okay, so this is average movie runtime by decade. Then we have genres. Okay, so we had another dimension called genres. So genres also had a list of different genres in which the movie falls. Okay, then this has also been split. This is genres in individual. I have created this dimension, and after splitting, we have just put this in the rows and count titles in the columns. So we can see that how many titles fall in which genre. And yes, we have the filter because we need only just the top 10. We need top 10 genres, which is why we have all these. It shows that the drama has the most titles. Here we can also see the 2600 titles fall into drama category, and then we have comedy followed by thriller. So why this chart is because when we see the most popular genres in the catalog, we can also see if that genre has been liked or not, and if we should include more movies and shows with which fall in that genre. If the rating and the audience response is not positive, we might not choose to include those content in our catalog. So we have second dashboard, which is content diversity and regional analysis. So for obviously all the four charts that we had studied earlier show content diversity and regional analysis only. So for regional analysis, we have this map. Okay? We can zoom it here or not. We can search it. So this is quite an interactive chart. Then we have title, release plus years, most popular genres, and average movie runtime by decade, and we have put the labels on it. Okay, this is also used the floating only because I wanted all the authority over the size of the charts and its contents, which is why I've used floating chart type. For the next chart, I have created top 10 titles by IMDb score. So we see average IMDb score across all the titles, which is being shown here. I put some labels so that we can see which are the top rated IMDb content. This is content because this is titles. And we have put the filter of movies and shows. So we can select to see only what are the top rated movies, top 10. Then we can see the only the shows. The next chart we are seeing is IMDb ratings versus TMDb ratings. For that, I have just used both of the measures in columns and rows, and we see a scatter plot. The reason that we see this and that we have done this analysis is to see if there is any correlation between the ratings, if the IMDb ratings are closely related or not related to the TMDb ratings, how do they differ. And it matters because the audience is wide, and so is the content. What is the relationship between these two ratings? We need to know that. From the analysis, we can see that they are highly correlated. They're not very much different. Any data point we see, there is not a big difference between these scores. So I've used this reference line, okay, reference line to show the average. This is the average TMDB score, which is 338, and this is average IMDb score, which is also 338. So the reference line show a high correlation between these two. The next chart we are going to see is TMDB score versus TMDB popularity. This is also a scatter plot. Okay, and I've used this line. Okay, this is actually the R squared line, which shows no deviations. Okay, so here we can see that for movies, the TMDB popularity is 47,000 and TMDB score is 49,590, which is fairly correlated, which is strongly correlated, we can see. But for shows, it is different. For shows, TMDB popularity is 17,746 and TMDB score is just 8,958. What we can see here is the shows get scattered response, but the movies show fairly same response. This can be the one reason for this can be the volume of movies in the US catalog and the volume of shows in the catalog. So this is also an important chart. Then we see IMDb rating distribution by type. Average IMDb for movie is 5.8 and average IMDb for shows is 6.9. That is very logical because we saw it earlier also in the histogram that we see from 5.5 to 6 the movies had peaked here. So the analysis overall makes sense because of the volume of the movies that are there in the titles, and the IMDb rating is very much normal. The distribution is quite normal, but it's not the case for shows. So we can see. Then we have made it a little bit interactive by putting the filter, and we come for the third dashboard. The third dashboard has been named audience rating and content quality. Okay, then IMDb rating by distribution type, then IMDb versus TMDB scatter plot, and TMDB scores versus TMDB popularity. This dashboard show the audience rating and content quality of the Amazon Prime catalog, and this is quite a representative for the viewers and for the stakeholders to see what it shows, what are the ratings telling, what are the quality content telling, and which movies show the big runs. Then we have top rated actors with combined ratings. So for star influence in the Amazon Prime content, it is important for us to understand which are the actors with highest ratings. The thing is, we can't just use one rating, which is either IMDb or TMDB score for considering the star influence, which is why I have created a calculated field called combined rating. Okay, so we'll show this. In combined rating, I have put the IMDb score plus TMDb score divided by 2. This is a simple average of both the scores. I have created another calculated field, which I'll show, which is average of that combined weight. I've used that calculation in columns and name in rows. Okay. For roles, I have actually used only actors, and only actors are important for the star influence. For directors, we have used another chart. So for actor, we have this, and we have this entire list. So we can see Ruth Goodman, Peter Jin, and all these actors having the average of 13.313 rating. This is interesting because Naoya Uchida is not a US actor, or Tomoko Kawakami is not a US actor. We know that the Prime catalog includes more than 50% of US movies, US produced movies, but the actors or the star influence has been scattered between different countries. So Japan seems to be dominating here, Hiroki Hirata or Hiroki Yasumoto. This is important, or Lee Zefang. All these actors who have been rated highly by both the audience, IMDb and TMDb. So Amazon Prime should include more of their titles, more of their content, to improve the audience retention. Which is why this top rated actors chart makes more sense and is very crucial for our analysis. The last chart we have is for directors. So in here what I have done actually is we have used a filter for directors, we have names for director, and then we have average titles per director. I have created this calculated field where you can see that this is average titles for each director, and I've put it with the bars, and this is actually the rating. This is average combined rating for IMDb and TMDb scores, which have been shown by the line chart, and I've used this dual axis for showing the directors which have been rated highly and have good volume of content in Amazon Prime. And the filter actually is for the directors which have 20 plus average titles. The reason for this range is because as directors with less number of titles are included in the analysis, it doesn't show the popular trend. The popular trend will come with the volume, and which is why we have used more bigger volume. Okay, the scatteredness which I had seen earlier was actually that there were very less directors with very high number of content. Like we can see here, if we use just something like 30 to 40, we have just 4 guys here. Okay, so what we use is we use the basic mean, and that will be the range. So we'll make it 20. Okay, make it 20. So we have final dashboard, which is for actors and directors. These are top rated actors and these are top rated directors, and we have our filter pane over here. So I'll wrap up this. What I'll do is I'll just keep the 4 dashboards. This one's the first overview, then we get content diversity and regional analysis, then we get audience rating and content quality, and then we get the star influence. Thank you.